Now, why would you ever want to use R for such a problem? Now, for such a problem, you can use Excel a lot of times in, with a real problem because it's actually good at that type of thing. But when you get lots and lots and lots of constraints with lots of data, then it starts to get harder and R becomes a better choice. Also, when you get a more complex problems where there is non-linearity, right? We've been doing linear programming. When there's non-linearity, so for example, a lot of times there might be an economy of scale, like the more money you pay, the more ROI you get at a particular media outlet. That would be an example of a non-linear relationship in your algorithm. There are options within R to solve optimization problems that way. It wouldn't be technically speaking linear programming, but it would still be, decisions, constraints with a minimization or maximization goal. But you would use sort of a different algorithm, and there are libraries and packages that you can install for R to do this. So you would start by typing in install.packages to do the basic linear programming, and in parentheses type linprog, and that will bring up a selection. We'll pick Texas as usual. Okay, and that will install the linear programming library. With a more complex problem, you might want to check out the documentation on linear programming and optimization libraries that are already built for R. Okay, now we can just type in library and linprog and loading required package lpsolve. Okay, it looks like that should be loaded. Now we need to create some data, the same type of thing that we saw in our Excel file. So I'll type in ROI equals. This is going to create a row of numbers, or an array of numbers. Remember, our ROI for one of the outlets was 0.09 and 0.14 for another, and 0.10 for another, and 0.05 for another. So the 0.09 was the ROI for the TV ad, the 0.14 was the ROI for SEO, 0.1 for Google AdWords, and 0.05 for Facebook. And we click enter, and we have our ROI. We have our array of numbers for ROI. Now we're going to put all of the right-hand side. Remember, we have our constraints, and we're going to have two sort of data containers. One is going to be a vector, and one's going to be a matrix. And we're going to put all of our constraint, the right-hand side of the constraint, in the vector. So I'll call it bvect. And this is just going to look like what you saw in Excel. So those numbers were, remember, we had a budget of $1 million. We're going to reduce that to $1,000 here just to make the numbers shorter. And then for a couple of the other ones, which you'll see in a second, the constraint really didn't have much to do with the right-hand side of the equation. And you'll see what I mean in a minute when we type in the next one. I'm going to put a negative 200 there because that was our minimum TV cost, 200,000. And then I'm going to put a negative 80 there because that was our minimum cost for the Facebook agency. I'm going to put in a negative 60 here because that was our minimum cost for the SEO agency. And then I'll put 220 here because that was the maximum cost for the SEO agency. And I'll put in another 0. You'll see where that comes into play, where we wanted our AdWords to be less than or equal to 3 times our SEO. And then I'll put 1,300 here because that is our market size. So all that data goes into the bvect. Now we'll create our matrix. We'll call that the A matrix. And we'll make our set of numbers here. Rather, we're going to use rbind, and we're going to create these rows within this. So just think of this as a square of numbers where each of these C's is a row. Everything in C's is a row. So we have our total, which was, right, for each of the channels, 1, 1, 1, 1. When you add them all up, they should be less than or equal to 1,000,000. So those 1, 1, 1, 1s, that's going to be multiplied, and we're going to make sure that this stays within that range of 1,000 when you add them all up. And then for the next one, we want to have our SEO plus the AdWords being greater than 60% of the budget. So how do we do that? We put a 0.6, negative 0.4, comma, negative 0.4, comma, 0.6. And what this is saying is that, okay, so we have our SEO and AdWords represented here by 0.14 and 0.1. And when you add those together, what's left over in the budget should be, 40% of the budget. That's what's going on here with this notation. And then I'm going to put a C for, this is going to be for Facebook less than 20%. I'm going to put another row of numbers here, and that should be negative 0.2, comma, negative 0.2, comma, negative 0.2, comma, and then 0.8. And so that is saying that, right, so Facebook was the last one in this list. We get a 0.05 ROI for Facebook. And we want to make sure that when Facebook is, when we spend money on Facebook, we want to have at least 80% of the budget left over. That's what that number is representing. And then the minimum TV, so we're just going to put in some negative numbers here. So the TV one was the 0.09, so that's going to be minimum negative 1, 0, 0, 0, comma. And the minimum Facebook, so that's going to be 0, 0, 0, comma, negative 1. And you can see I've got these minimums up here. The minimum for the TV was 200. The minimum for Facebook was 80,000. And then we also have a minimum for SEO. So comma C. And the SEO was, I believe, the second one on the list. Yep. So 0, comma, negative 1, comma, 0, comma, 0. So at minimum, it's going to be 60,000 rather. And then the maximum, check this out, C, and we'll put 0, comma, positive 1 this time, 0, comma, 0, comma. And that's this positive 1 again, just like the last time, it's corresponding to this 220 here. So that's our maximum. And then the AdWords needs to be less than or equal to 3 times the SEO. So here's how we'll pull that off. We'll make another row of numbers, and we will say 0, comma, negative 3, comma, 1, 0. And so that's saying that this should sort of like balance out, right? The 1 for the AdWords should be less than or equal to 3 times the SEO. And that's corresponding up here to this B-vect with a 0, all right? And the final one is our reach, so our campaign reach. So we're just gonna put in the numbers that you probably remember from the Excel example where we have our sort of impressions per dollar for each channel. So we had 2.5 for the TV ad, 2.1 for SEO, 0.9 for AdWords, and 3.0 for Facebook. Close that off. Oops, it was already closed. Click enter. All right, hopefully I didn't make any mistakes there. Now the final step to do this is type in solve. Solve. And we're going to throw in our ROI row of numbers. And we're going to throw in the B-vect. And we're going to throw in the A matrix. And we're going to say true. And I'll explain what that means later. A matrix not found. Oh, because I capitalized the M. Let's make that lowercase. Error in solve, default, ROI, B-vect, A matrix, true. A, 4 by 1 must be square. Okay, so I just outputted the A matrix and that looks good, and then I realized how careless I was because the I'm going to go back here, I'm just pressing the up key to get back to the last commands. that I typed in. I forgot it's not actually solve, it's solve LP, solve for linear programming. All right, so now we get this output, and you see how fast that happened, and you can see that we got this same result that we got in the Excel file, $73.333, whatever, but that should be multiplied by 1,000, so right, 7,333. And it's giving us these same numbers that we got in the Excel file. So it's saying 200 in, you can think of these as thousands of dollars, 200,000 for the TV ad, 116,000 for SEO, 350,000 for Google AdWords, and 80,000 for Facebook.